Hello and welcome to another video of Grokking the coding interview series in which we are going through the sliding window pattern. And in this video, we'll have a look at longest substring with same letters after replacement, which is classified as a hard problem. However, we'll stick to our sliding window approach as we are going through that method and try to solve this problem for from that approach itself. In the later problem solving sessions, we will be imitating more of an interview environment where we will be going through both the brute force as well as the more optimal solution once we try to solve the problem. So let's have a look at some of the examples which have been provided here. Given a string with lowercase letters only, if you're allowed to replace no more than k letters with any letter, find the length of the longest substring having the same letters after replacement. So in this case, the k is 2, and what we want to do is we can replace 2 of c and 2c and b with b to have the longest substring, which will be a contiguous set of b's here, and the length will be 5. So as an output, we have to return the max length. In case the k is 1, we can either we can go ahead and replace c with a b, and we'll have a string again with a contiguous b's of 4. Here we have k as 1, and in this case we can replace either bd with a c to have ccc as the longest repeating substring in our case. So we do have an idea of what it means to work with replacements. So what will be our first approach in this case? Or what will be the optimal approach looking at that we already know about the sliding window approach? So essentially what I want to do at this point is I want to have a sliding window, and as we have been implementing most of the previous algorithms, it'll again start at the window start. We keep on increasing the window end. What we'll do is we'll maintain a char frequency hash map where we keep a track of frequency of each element in that window. And in this example, what we in addition want to do is we want to keep a track of the maximum repeating letter in that window. So, for example, if we are in this window, I want to keep a track of which is the maximum repeating letter, which will be B, and the frequency will be 3. And this would allow me a flexibility to check uh, in this window size, can I replace k elements, or the other elements are less than or equal to k, or more than k. If these elements are more than k, essentially what I want to do at this point is I want to shrink the window, and we already know the mechanism of shrinking the window. Again, our means of approaching this problem remains the same. The structure will be very much the same, and yeah, so let's try to implement and see how we can come up with a solution here. Let's try to extend this, and we'll also be speaking about the runtime complexity at the end of it. So again, we do have the protocol of how we approach these problems. So we have a max length, we have window start, and we also have max repeating letter count, and all of these will be initialized to 0 to start off with. We also have a char frequency hash map which we want to maintain. So again, let's initiate our loop as we have been initiated for all the problems prior. So for window and in range, the length of the stir one, star 1, we can extract the character at this point. So this will simply be, we can index using window end. So at this point, what we want to do is we want to go ahead and upload the char frequency hash map. So is if char in char frequency hash map, then we simply go ahead and increase it by 1. Else we go ahead and initialize it. And initialize it to 1, of course. At this point, what we want to do is we want to extract the max repeating letter count in this window. And let me do a correction. Max repeating letter count. So max repeating letter count at this point will be, let me try to spell it correctly. Letter count will be a maximum of the max repeating letter count, which we are already keeping a track of. I cannot copy it from there, so I need to write it down. Or it will either be the frequency of the letter which we have just included in the sliding window. So it can be char frequency char. So once I have the max repeating letter count in the current sliding window, I'm ready to go ahead and introduce the condition I want to use to check this sliding window. And the condition will simply be, I have to see if, let's see, window end minus window start plus 1 and minus the max repeating letter count. If this is more than k, if this is more than k, it means that I have an excess of letters I can replace. So essentially, what I'm doing here is I'm extracting the length of the current window. I'm extracting and I'm subtracting the maximum repeating letter count from that window and seeing how many letters am I left with. If it is more than k, it means I cannot go ahead and replace all the remaining letters. It would mean that I would have to go ahead and shrink the window in order to make sure that the primary imposed constraint is still valid on this window. So at this point, what I want to do is I want to reduce the frequency of the window start element as we are shrinking the window. So star 1, window start. I want to go ahead and replace the frequency of this character. I also want to go ahead and increase the window start by 1. And this would satisfy how I want to shrink the window moving forward. Like this is the only operation which I want to do at this point. And once I have shrunk the window, I'll go ahead and calculate the maximum length, which will be either the max length, window end, window start plus 1. And at this point, I can just go ahead and return the max length, and this would provide me the answer I'm looking for at this moment. So if you see again, it's a hard problem from the classification point of view. So if you were encountering this problem without any method in your hand, of course it'll be hard because then you will be brute forcing a solution. But given that we have a sliding window approach most of these problems can be broken down into simpler blocks of how we approach it. It's usually a traversal using window end. Then we have a condition of how you want to expand or shrink the window. And at the end, we just calculate the value which we need to like have at the end. So what I'll essentially do at the end of the sliding window series is also go ahead and summarize all these steps so we can revise them when required. But let's quickly speak about the runtime complexity at this point. So as you see, and in most of the previous implementations, we see the runtime complexity is basically O of n. As we are iterating through the array only once, let me quickly do this. And we again have a char frequency hash map uh, where we can essentially store all the characters. So, and given that we have a constraint on the number of characters you can have in English, so essentially it will be O of 26. So this will be a constant space implementation as well. Let's quickly verify if our implementation is right or in case we have any errors. And we do have some errors. Too many values to unpack. Okay, we only have three variables here. Okay, so it seems like our implementation is working fine. I hope you found the explanation clear. Please let me know if I can improve anywhere. And until the next video, have a great day.